Okay, here we want to talk about infinite limits. And for example, here we have f of x equals 1 over x, and I've given you the graph. We know that there's a vertical asymptote here at 0 because we would have division by 0. And if we look at our one-sided limits, for example, the limit of this function as x approaches 0 from the left, what do we end up with? Well, if we're approaching 0 from the left-hand side, our graph is going down and it's approaching negative infinity. In other words, the graph is continuously going down, so our limit is not approaching a number, it's constantly getting smaller, so we could say that it's going to negative infinity. So we could actually put this as an answer. Now, when I say the answer is negative infinity, I'm not saying that the limit is a negative infinity. This is more of a way telling you why the limit does not exist. For example, if we look at the limit of the function as x approaches 0 from the right, what's happening to our graph? It's going up constantly, so it's approaching positive infinity. So here we could say that this limit is approaching infinity. Now, I really want to emphasize this. Here, with these two examples, I'm not saying the limit is negative infinity or positive infinity. That's more of a way of telling you why the limit does not exist. So technically here, the limit for both of these does not exist, and the infinity and negative infinity basically tells you how the limit fails to exist. Okay, so let me even emphasize this again. We're not saying the limit is negative infinity. We're just saying that that's more of a way of explaining why the limit does not exist. So you'll notice that a lot of times for an answer here, if your limit is going to negative infinity or if it's approaching positive infinity, you could say the limit does not exist, or you could be more specific and say the answer is infinity, but you're really emphasizing how the limit fails to exist. So down here for the two-sided limit, as x approaches 0, we're looking at it from both the left and the right. So you would just simply say the limit does not exist. So you could say the same thing here. As x approaches 0 from the left, we could say, well, the answer is the limit does not exist because it's going to negative infinity. And the reason we would say it does not exist is because it's approaching negative infinity. In other words, it's constantly getting smaller. But you will see that sometimes they want you to emphasize why the limit doesn't exist, and the answer would be negative infinity because it's constantly getting smaller, and for 0 from the right would be positive infinity because your number is constantly increasing. And what this tells us is when you have this infinite limit here, it's increasing or decreasing without bound, negative infinity to positive infinity. That's also going to tell you, based on this limit, you're going to have a vertical asymptote at this positive infinity or negative infinity. Because what that tells us is there's an actual split in the graph, which means you will have a vertical asymptote at that point. So that's another way that we can identify vertical asymptotes. If we look at the function here, we have x squared plus 2x minus 8 divided by x squared minus 4. And if I said I want you to find the vertical asymptote, well, how could we do that? Well, if we want to find the vertical asymptote, well, one of the easiest way is we could simply take our function and factor. And if we factor the numerator, we get x times x, and we have what, 1 and 8 or 2 and 4, and it looks like we would end up with what, 4 times 2 is 8, plus 4 and minus 2, and the bottom is a simple difference of squares, so we could factor x plus 2, x minus 2. And this is one way you might have learned even from pre-calc that we can determine a vertical asymptote and a hole in the graph. And we've talked about this earlier. We notice that the x minus 2 factor cancels. So that tells us that at x equals 2, there's simply going to be a hole in the graph. And the other factor, the x plus 2, that means x equals negative 2 is going to be your vertical asymptote. The factor doesn't cancel out. So at negative 2 over here, we're going to have a vertical asymptote. Okay? And we know that at x equals 2, there's going to be a hole in the graph. And that's roughly going to occur right about here. And I know from putting this graph into the calculator, the graph of this function is going to look something like this here. Something similar to this. And if we want to calculate the limit, now we know that this function is undefined at negative 2 and positive 2. And if we were to calculate the limit of this function as x approaches 2 from the left, what does that equal? Well, if we're approaching 2 from the left, that's over here, well, it looks like it's getting closer and closer to this point right here, which happens to be 3/2, or 1.5. And if we were to calculate the limit of this function as x approaches 2 from the right, whoops, this should just be a negative up here. So if we're x is approaching 2 with a plus sign, so we're approaching it from the right-hand side. So if we approach from the right, once again, we're still approaching the 3/2. Okay, and because this hole in the graph, we know it's removable, we could simply have used direct substitution. If we would have took the 2 here and plugged it in for x plus 4 over x plus 2, you would end up with 6 over 4, and 6/4 would reduce to 3/2. So we could have used the direct substitution, which means if we were to calculate the limit, then as x approaches 2 from both sides, because the left and right both equal 3/2, that means that the limit from both sides is 3/2. So again, this x equals 2 would be a removable discontinuity, and when we calculate the limit from the left or the right or both sides, we know that we end up with this 3/2. Now, what's going to happen if I want to look at calculating the limit of this function? Our other discontinuity was at negative 2. So what happens if we look at as x approaches negative 2 from the left? Well, if we approach negative 2 from the left-hand side, here your graph is going down to a negative infinity. So we have a negative infinity, and I'm going to emphasize this really tells us our limit does not exist. And if we were to look at the limit as x approaches negative 2 from the right, Well, over here, if we approach it from the right-hand side, again, our limit is going to a positive infinity, which means our limit does not exist. So then, of course, if we were to calculate this limit, as x approaches 2, because of the infinity and negative infinity, we clearly know the limit does not exist. And what does that tell us? Because of the infinity and negative infinity, we know the graph is going to split, which again, that emphasizes that at -2, we have a vertical asymptote. So once again, if your limit from the left or right is going to infinity or negative infinity, that tells you that at that number, you're going to have a vertical asymptote. Now, we pretty much knew that algebraically because over here, the x plus 2 factor didn't cancel out. But based on the idea of a limit, if it's going to infinity or negative infinity, you're going to have a vertical asymptote at that point. All right, one last example here. If we look at the limit of 1 plus 1 over x squared, there are some properties with limits. We can actually split this up. And we could split this up to calculating the limit of 1 as x approaches 0 plus the limit of 1 over x squared as x approaches 0. Well, we know that if we take the limit of 1, that goes back to our property of we're taking the limit of a constant function, and the graph there of this function would be just a horizontal line at 1. So the limit here, the limit of 1 as x approaches 0, well, if we approach 0 from the left and 0 from the right, our y value is approaching 1. And then if we look at the limit of 1 over x squared, well, here's the graph of 1 over x squared. If we approach the limit there from the left and from the right, both of these are going to infinity. So that means the limit doesn't exist, or we could say it's going to infinity, which means it does not exist. And if we said 1 plus infinity, well, an infinity plus 1 is still infinity. So that would be your answer. Or once again, realize that means the limit does not exist. The infinity is simply telling you why the limit does not exist.